Be speaking to you by video, but while we're having this meeting here, we're off at another place in a conference, but we'll be back next week. So I wanted to introduce myself, Dave Dornfeld, Professor Dave Dornfeld, and my co-conspirator for the class, Margot Hutchins. Dr. Hutchins and I will be trading off on the teaching of the class and both be engaged during the entire semester. So did you want to say anything, Margot, before we get started?
I don't think so.
Okay, perfect. So what we're going to try to do today is we're going to go through a list of the background information for the course, talk about the syllabus and organization, and then we're going to plunge right into the material and talk about some of the motivation and issues that deal with why we're teaching this course, some definitions, of course, how to put sustainability in engineering context. We'll try to do that. Of course, we can't do it all in one lecture because that's what the whole course is about. Then about sustainability in a manufacturing context, and finally what's going to happen next. So let's get right into the presentation of the material. These slides will be posted on the B-Space site after the class today, so you are welcome to go back and take a look at them in more detail. And in fact, we're going to do that with all the slides throughout the course of the semester. So here's some things that I think will make you think a little bit. These are by two very famous Americans, Groucho Marx and Dan Quayle. I don't think most of you were alive when Dan Quayle was a former vice president, but they sort of sum up a lot of what people think about sustainability or what their responsibility is. So Groucho Marx wants to know what future generations have ever done for him, and Dan Quayle is quibbling over the distinctions between pollution and impurities in our air and water. So people have been thinking about these things on and off for some time, but in fact, their thoughts are not often very well formalized. And in fact, part of our job is to actually determine the definitions, understand exactly what we're talking about. There are a number of resources, both online and in paper version, that you can take advantage of. I'm going to show you a copy of the textbook, Green Manufacturing, which is a brand new book published by Springer, which has just come out. The good news is you don't have to buy it because the University of California has an arrangement with Springer whereby all of this content is available to you for nothing online if you log in, if you follow the information on the screen through the Kresge Engineering Library. There's a bunch of other reading and resources items here. These are also available online, so you don't have to download those or you don't have to pay for those. And we'll be referring to those. Right now they're not integrated into the syllabus, but we'll be integrating the reading in the syllabus as we go along in the course of the semester. And the very bottom line says that B-Space is kind of the place where all the good stuff for the class is going to be organized. So you should be, if you haven't already logged on to B-Space, you should be doing that. We've organized the course to the extent possible into a series of modules, 9 different modules, which you see on the screen right now. I'm not going to read through them because you can read them as well as I can, but they're either in 1 week or 2 week or sometimes 2.5 week segments, and they kind of follow thematically the direction of material that we're going to be covering in the course of the semester. And the syllabus that follows is going to be on the next slide, and perhaps you've already downloaded it from the website. You can see where these things fit in, but they give us a good coverage, motivation, business case, moving through sustainability, different materials, energy, water, etc., and then of course some applications and some other tools that will be used in the course of our studies. Tend to be better off, lifestyles to be better, depending upon if you agree with definition of better or not, than countries that have lower GDPs. So this may be an interesting topic. If you want to do a study with a group on how you define how well people feel, how happy they are, how well they're living, or lifestyle issues, that may be something to think about. But for the purpose of this slide, GDP is what we're going to use. On the bottom axis is energy efficiency, which is essentially dividing the GDP, the gross domestic product, by the amount of energy that the economy uses to create that GDP, okay? And what you see is, up in the upper left-hand corner, so-called highly productive or highly developed countries, the United States, Canada, the G7, etc. So they have essentially characterized as relatively inefficient use of energy to generate their GDP. So we use a lot more water, a lot more electricity, a lot more of other resources to cover our lifestyle than other places. For example, if you go on the bottom right hand, moving way out on the scale, for example, the Philippines or Bangladesh, who are exceptionally energy efficient, but have comparatively very low GDP. So one can argue about, again, whether these are the right parameters to use, but the question is, most countries are trying to move up and to the right, meaning they'd like to have higher energy efficiency, but they'd like to have a higher GDP. So that's why the little circle up in the corner, is this really where we want to be? So we're engineers. To some extent, these discussions are based upon political considerations or other considerations. But as engineers, we have a responsibility to at least try to have people live as well as possible in the most efficient way that they could do this, right? Using energy, materials, resources as efficiently as possible. Whether you agree to that or not, or you think that's the right thing to do or the wrong thing to do is another thing we can get into. But from the point of view of engineers, if we're asked to do that, we should have the tools and the capability to do the analysis and understand how we could move forward in that direction.
So I just want to step in. So my job here today is just sort of provide my 2 cents here and there as Dave's working through this lecture. So one little piece I want you to think about when you're looking at this chart that's labeled GDP versus energy efficiency is that the y-axis is GDP per capita and the x-axis is GDP per BTU. So food for thought is, well, what's the effect of both of these axes being related to GDP? What are we actually looking at here? And so the answer is we're actually looking at population and energy usage. That's right. In my opinion. Which is important to know.
And is the perfect segue to the next slide.
There you go.
Thank you. It almost looks like we planned this.
We are a team.
Yes. So there is something called the IPAT equation, and this is it. IPAT is impact is equal to population times affluence times technology. So this is not exactly rocket science, but essentially it talks about if you're trying to look at the impact of a particular piece of technology, say that impact is CO2 footprint per unit of GDP, or energy consumed per unit of GDP, or water consumed, or whatever, or toxic substances per unit of GDP. That's in the right-hand part of the equation, the impact per unit of GDP. You multiply that by the GDP per capita per person, which we saw on the previous slide. You multiply that by the population, and that gives you a sense of the impact which is caused by the confluence of technology and affluence on a population which is always increasing. So that's why impact curves always start low in the lower left-hand corner and get higher in the upper right-hand corner. So we can't do anything about population, right? I mean, population will grow the way population grows. If you believe that affluence is represented by GDP per capita, then we can't really frustrate people's efforts to be more affluent. People would like to have better lifestyles. They all want to reach the middle class or whatever, however that's defined. But anyways, people want to have a better lifestyle. What we can't do is affect impact per unit of GDP, because that is essentially given a piece of technology or a product or a service or whatever that delivers some value to the customer, to the segment of the population. We can either do that in a way which consumes a lot of resources and energy, or consumes very little or less, okay? If we consume less, we assume then the impact is less. So the way to really reduce the impact while in the presence of increasing population and increasing aspirations of higher affluence is to offset that by having decreases of some substance in the amount of impact per unit of GDP. So that's where engineers come in. This is the only thing that we can really have an influence on, by making sure that the technology that we develop and implement, utilize, treat its end of life, etc., is in such a way that the value that's delivered is represented by the GDP to the consumer has a lower and lower impact per unit of device or value. So that's what we're going to try to look at. Now, we can't accomplish this all in one swatch, and you're going to see a slide a couple down in here where we talk a little bit about where sustainability fits into this, but we talk about the technologies that we'd like to develop that would reduce this impact per unit of GDP. And we'll get into some of the other measures of affluence. I mean, the French have something called gross national happiness and a few other things. Those are a little harder to quantify, but this at least is easy to quantify, even though it may not be as accurate as we'd like to have. So speaking of technology, let's just step through a couple of pieces of data relative to this iPad equation. Here it shows that the consumption per dollar of gross domestic product has been decreasing over time in the United States. So to some extent, we are either getting slightly better at delivering product or things measured by GDP in terms of the amount of energy that it takes. But at the same time, if you look at the consumption of energy, right, one was technology or energy per unit of GDP. This is now energy consumption from all the different major sources, fossil fuels down to nuclear and renewable, et cetera, on the bottom. It's been going up and to the right at a very prodigious rate. So you're going to see a dip here, 2009, so because of the recent recession, but in fact, the curve is just to keep moving up. Population growth, depending upon what kind of estimates you use, is also moving up and to the right. So the US has a reasonable population growth, which meets the demand of the economy, et cetera. Other countries are a little bit higher, some countries are a little bit lower. But so if you think about the elements of the iPad equation, population is going up, we expect GDP per capita is going up. To some extent, the impact per unit of GDP as measured by that first curve may be going down, but it clearly isn't enough if you think about sort of buildup of CO2 in the atmosphere, et cetera, the things that we're pushing ourselves to try to do to become more sustainable. So what does sustainability mean? I'm glad you asked that question. This is actually sustainable development. You've probably seen this. Is from the Brundtland Commission, 1987, and it defines development that meets the needs of the present without compromising the ability of future generations to meet their own needs. So you should make it so your children and your children's children are no worse off than you are. Okay, so that has to be, of course, defined in terms of specific terms as engineers, and we're going to get into that. I mean, that's what the whole course is about, especially as it maps onto the manufacturing space. The US Department of Commerce has a definition related to sustainable manufacturing, which is a bit more specific. So it talks about creating manufactured products that use materials and processes, but minimizing negative environmental impacts, conserve energy and natural resources, safe for employees, communities, consumers, and are economically sound. So this is not bad. We're going to quibble about it in a little bit because to some extent sustainability is you either are or you aren't. It's not like being a little bit better than you were the day before, and I'll show you an example about what I mean by that. But this is getting better. At least it begins to map it down onto a manufacturing space. I would argue, and I think Dr. Hutchins would agree, green manufacturing is at least a first step towards sustainability. And I'm going to talk about why this is. So you have to make incremental improvements and things that make manufacturing more green to the extent it builds up to make a process or a system more sustainable. Green manufacturing is an important first step. So that's why we're sort of interweaving green manufacturing and sustainable manufacturing into the class during the semester, because it needs to talk about the building blocks of what makes a process or a product or a system sustainable, and we would talk about those as being individually green steps or technologies. Now this turns out to be a controversial slide because Dr. Hutchins and I don't necessarily agree on the title and all the things that are on there. So here's what happened. So when I started talking about this probably 10 or 15 years ago, companies wanted to know, people wanted to know, well, so what do you mean when you're talking about it? And what this really is how do we define maybe impacts such as we had in the iPad equation that relate to sustainability? So that might be perhaps a better title. We'll see in a minute because I'm sure she's going to chime in on this. So one, for example, would be global warming gases emissions. So how much CO2, methane, other gases is the process or the product or the device giving off? Is that measured per capita, per GDP, per area, per nation, per region, per economic sector? Are the materials or the product recyclable? If they're recyclable, can you reuse the materials? Okay, as opposed to recyclable and going into a furnace or something. How much energy consumption? So CO2 is often a proxy for global impact or environmental impact. CO2 is also often transferred from electricity or energy use as a way of converting energy use into environmental impact. Are there air, water, or land pollution or is there air, water, or land pollution that's generated as a result of the product or the process? We're going to have a slide or two about something called fair share. Are you using your fair share, or are you using more than your fair share of the resources that are associated with you? And so this could apply to you as an individual, you as a corporation. I realize in the last election there were people that said that corporations are individuals, but won't get into that. But it could be to a number of different scales. And finally, you could have some sort of a thermodynamic measure like available energy or exergy or things like that. So if these are things that are impact drivers, then one would like to find a way, if we're making some improvement or we're greening something, if we have progress. So in the business world, you measure a return on investments. You make an investment in a technology, and you look at how much it cost you and how much you get back by gain, either by productivity improvements or additional profit or whatever. So we might think about that in terms of these greening efforts that we do. So if you invest a little bit of energy or resource to make a process more green, will the effect of making it greener give you at least as much as you invested, and will it pay back a little bit over time? So you think about greenhouse gas return on investment or energy payback time, like you might do that with a solar panel, for example. You put a solar panel on the roof of your house and it took 3 years worth of operation at the output of the solar panel for where you're located to pay for the energy that went to make the solar panel, then you're actually net positive after about 3 years. So things like that. Water, material payback time, carbon footprint, decrease in the carbon footprint, some efficiency, thermodynamic efficiency improvement. So these are things that we would be talking about, and you're going to see those coming up later in the slide set. So do you want to comment a little bit about your
Sure.
take on this?
Sure. So Dave and I have a little bit different backgrounds. I would argue that Dave's background is more strongly in manufacturing and green manufacturing, and my background is very focused on metrics, sustainability, and even social sustainability and how that relates to manufacturing. So when I look at this slide, what I see is not necessarily a definition, but a series of metrics that manufacturers have used in the past to sort of define or describe their sustainability. And I think it's really important that Dave noted that this is from a manufacturing perspective, because there's certainly other perspectives on what metrics should be used. So like the International Organization for Standardization, ISO, has a document on social responsibility and sustainability. And they have a whole suite of metrics in there that include these, but also include issues related to human rights and labor rights. Similarly, the UN has series of metrics in different contexts for use by corporations and manufacturers that include sort of a broader spectrum of issues. So I think that these metrics are representative of what's being done in sustainability, but I want you to be aware that there's sort of a broader suite of issues that are being brought in as sustainability or social responsibility issues, and do have an effect on how manufacturers and companies are doing things. Well said. Well said. So this will come out, these are the more nuanced things that'll come out in the course of the semester. Mm-hmm. Let's look at a graphic cartoon that I like to use to describe sustainability, and see if you agree that this is a good way to do it. So what you see on this curve, on this graph, is a bunch of curves, and the x-axis, or sorry, the y-axis is basically, vertical axis is talking about a rate of consumption or impact. So this could be the rate of use of energy, could be the rate of use of water, it could be the rate of generation of CO2 from a process, it could be the rate of generation of any sort of other toxic material or just waste from the product. Okay, so usually, unfortunately, the rate of consumption and impact, as we've seen in some of the curves, is going up and to the right. Now this is not per GDP or per capita, this is just kind of a number. Along the y-axis, or x-axis, is time, okay. We can usually define for a consumption rate or an impact rate a sustainable rate. So for example, in California, where we are now, the rain that falls as snow in the mountains during the winter stores up, and we use that for drinking water during the summer. It also fills reservoirs, so we have a certain amount of water that's available. And at our rate of consumption of that water, if
if, you know, sort of at the 365th day at the end of the year, the last drop evaporates, then essentially we are just at our sustainable rate, of course, assuming that it replenishes the next year. If we use water at a higher rate, we're not sustainable. If we use water at a lower rate, we're actually building up some capability for the future. So if you think about sustainability then as being like a balanced budget, if you're spending more than you're taking in, to use a fairly common phrase being discussed these days, your budget is not sustainable. If you're spending just what you're taking in, then you're at a sustainable rate. So meaning it can last for a long time, and meaning in terms of the Brundtland Commission's report is you're not doing anything that prejudices the future of future generations, but you're at least making sure they have the same resources and the same opportunities to the extent that leads to them as you do. So if you try to think about what we need to do from where we are presently, right? So bend this curve from this ever-increasing consumption or impact rate back to a sustainable rate, depending upon what it happens to be for whatever system or impact, whatever impact you're talking about, whether it's energy or CO2 or whatever. We have to essentially bend that curve. So there's a big gap involved. And to try to do that with one silver bullet or one silver technology or whatever is not going to work. So we talk about the idea of using technology wedges. So technology wedges are kind of green elements that essentially drop a little bit off, right? Either reduce the impact, remember our iPad equation, impact per unit of GDP, or reduce the consumption just a little bit. And you can think then about having a series of these are supposed to line up back at the origin, where if you add a bunch of these, if you add a bunch of these together, and the bunch may be tens or hundreds, right? You essentially, for a particular technology, you can bend the curve, you get back to a sustainable level. So it might be thinking about what Berkeley's doing to reduce the landfill utilization by going to recyclable bags for your groceries, right? You can't use a plastic bag in Berkeley anymore. So everybody's bringing their cloth bags, or they're bringing some sort of a reusable bag, or they're selling you a paper bag. So these kind of steps help to bend the curve. And this came from, well, one last comment. This comes from the fact that engineers are good at building technology wedges, right? So what our job is, and what a course like this does, is sort of give you some ideas about how to build those technology wedges and how to define whether they're actually a positive step or whether they're not positive at all. This came from a series of a paper actually by Paklow and Sokolow from Princeton on what they called stabilization wedges, where they were talking about doing the very same thing with fossil fuel emissions. Fossil fuel emissions by looking at a number of alternate energy sources that would essentially take the business as usual trend of CO2 buildup in the atmosphere and take it back to a level that is considered to be sustainable, some number of parts per million. And they're suggesting that a series of wedges, and they came up with 8 or 9 wedges, which were rather beefy wedges in and of themselves, but essentially to turn this around. So if you apply that kind of idea to green manufacturing, we all have something we can do, and we can all pick our process and pick our area and see if we can make enough wedges to turn that around. Okay, let's talk a little bit about how people think about green or sustainability. So I've got a couple of slides. These have been advertisements from over the last couple of years. Obviously, if you watch television or read the newspaper or look at the internet, people are using green and sustainable as a marketing tool. There is something called greenwashing. You'll see a couple of examples as we move along through here. But essentially, people are understanding that consumers are interested in at least appearing to have a reduced impact for the value of the product they have. And some consumers, like in the Bay Area, for example, are very aggressively interested in doing that. And companies are looking at how to sell that, either Ford or Honda with hybrid vehicles, and looking at words like environmentology to describe what they're trying to do. The luxury brands are trying to figure out some way to make green be stylish, so you can have your luxury vehicle but still sleep well at night in your Egyptian cotton organic down-filled sleeping costume, et cetera, but so people are trying to use this as a way to get people to think about it's okay, and oh, by the way, I can sell you a product, and okay, if you buy this, then you can just don't worry about that. So we'll try to segregate that from the real activities. This is a Lexus commercial that is trying to give you the impression that they are exceptionally great. I have nothing against Lexus, by the way. I don't have one, but I mean, people are using this to try to do. It's where performance and the environment intersect. A hybrid with 438 horsepower. It's more than a car, it's a paradigm, right? And it's also a big gas guzzler. Anyways, but I digress for a minute. Here's another one that I thought was really nice. I'm from Wisconsin, and we have lots of lawn in Wisconsin. Here's Gravely, which is basically a lawnmower that uses a pivot mechanism so you can turn sharply. Say that they're green because they have a sharper turning radius. You can cut your lawn in a few less passes, therefore a few less CO2 particles coming out of the two-cycle engine. And here's my personal favorite from Arch Coal. Coal is green, just showing you if you say it often enough, people may believe it. And you know, they have a interesting challenge because there's a tremendous surplus supply of coal energy in this country, which if we just simply take it out and use it is going to be causing a problem, but it certainly offsets the importing of oil. Companies like Starbucks have been involved back in the early 2000s with using what they call the Eco Cup, trying to get more post-consumer waste involved. Most recently, they've come up with a scheme where they will try to get you to take or buy a reusable plastic cup, and if you bring it in, they'll give you a few cents off of your beverage, and you can therefore not have Starbucks use the paper cup, but you can reuse it. So this may show up later in a homework exercise to tell whether this is actually better or worse, or maybe at a wash. But anyways, it's an attempt to try to get people to think about. And this is something that engineers are not particularly good at, but Margot is going to bring up later in the semester, is how you start to change the consumer's behavior in response to an effort to both get value and be happy with the product, but to reduce the amount of resources or the impact of the product. So Starbucks is trying that. Yeah,
and just to supplement that consumer behavior piece, I think that this plastic cup campaign is another try at modifying consumer behavior. I think they've been providing discounts when people bring their own mug for quite some time. And they actually have a goal related to how many reusable cups will be used, and they weren't coming close. So they're like, well, we'll try something else. So they're providing a Starbucks cup that you can reuse. And I think part of it is this kind of cachet of having your Starbucks cup. And so this is a reusable Starbucks cup. So you can have the cachet, and they can count you as one of their reusable cup users. So they'll try anything.
You got it. No, this is, I mean, I think companies are really,
we're trying to figure out how to do it.
Later on in the semester, we're going to show you the results of a survey where people were talking about why people introduce sustainable business practices in their corporation. And the early bulk, they had like 25 different metrics, and the first 5 or 6 had nothing to do with cost. It was all to do with consumer perception, competition, you know, brand recognition, et cetera, et cetera. So, I mean, companies have caught this. But you got to be careful, right? What we're talking about this is companies have to do it honestly. Or if they don't do it honestly, I mean, sometimes, you know, marketing can be misleading. I know this is a shock, but it can be. So you have to be aware of what's going on so you can see through it. Okay, so we're going to be going to Europe next week. We're not going to be on an Airbus A380, I don't believe, but we're going to be flying. So if you look at our carbon footprint for the year, transportation is going to be a big chunk. But companies like, in this case, Airbus Industry, Boeing, they're looking at alternate fuels. They're looking at ways to reduce the impact per unit of GDP, so lighter weight structures, where you get a longer distance per unit of either fuel consumed or CO2 generated. And essentially, all these companies are looking at ways to do that, and they're relying on engineers to come up with these technology wedges. So read the slide when you download it from vSpace. It's got a lot of good information. Some organizations or some industries have been doing this for a long time. The semiconductor industry, which counts every penny with great detail on how much it costs to make a product, has been worried about energy reduction and water reduction and materials reduction because it goes right to the bottom line of the cost of their product. It's a very competitive industry. In addition to some places in the world where we make semiconductors, there isn't a lot of water, or there may be energy limitations. So they've been working on this very seriously for a long time. In fact, in our own lab, how we got into this whole green manufacturing area was through some work with the semiconductor industry on processing the effluents from a semiconductor processing tool, as well as how to make better use of the resources in the tool itself. Now, I mentioned fair share a couple of slides ago, and I think some of you have seen this, but if you look at a label that talks about how much resource, water, energy, materials goes into a product, you'd be surprised at things that don't seem to have any, say, water in them, like my laptop. Okay, if you shake it, you don't hear anything gurgling, but there's a tremendous amount of water that's gone into manufacture the laptop. So part of our discussion later on is to make sure that people understand that manufacturing plays a role in solving this problem and reducing impact for GDP, but also looking at other ways to determine how you use resources and how you utilize with efficiency of your resources. So your footprint is kind of how much of your share of the world's resources you use. There's a website, you can go to this, some of you may have done that. There's several that are online that will ask you a series of questions. There's also one for slavery, right? I think how many slaves,
slavery footprint, yep.
How many slaves do you employ, and usually it's related to your clothing or other products. But so this will go and it'll ask you a series of questions, like, you know, how big a house do you live in? Do you eat meat or vegetables? Do you commute? Do you ride your bicycle? Do you take bus? Do you drive to work? How much air travel do you do, et cetera, et cetera? And it then sort of has an interesting procedure, and you can perhaps argue or quibble about the math involved. But essentially you take all the world's resources, you divide it by all the people, and that says each person gets this much. And it'll essentially tell you how much of your share of the world's resources you are consuming. I will be the first to admit that I'm probably at least at 3 or 4x. There's almost no way I can get below that right now. There was an interesting study by some MIT guys, Gutowski, in a class very similar to this that he taught at MIT, where his class did a study, and they found that even if you're a homeless person or a Buddhist priest in the United States, you're still using over your share of the Earth's resources, because I suppose if you're a homeless person and you're sleeping under a bridge, then that bridge is there. In other places in the world, you don't have that bridge. So I'll get you the paper if you're interested, but it's a fascinating study. In this country, we are so programmed to use more resources than our fair share. But on the other hand, we have a very nice lifestyle. So this is a quandary, and we'll have to think about how to get around this. But this is a good way to kind of see how you do. Okay, I'd be curious to see how you do. Now, another definition of sustainability, so sort of honing in a little bit more on sustainability, comes from Paul Hawken. This is on our reading list. It's a good read. It basically talks about, you can read a whole series of things. Your business must deliver clothing, objects, foods, or services to a customer in a way that reduces consumption, energy use, distribution costs, economic concentration, soil erosion, atmospheric pollution, and other forms of environmental damage. Leave the world better than you found it. So that's a little bit more in your face, okay? It talks about a whole range of things. It's simply saying, well, you know, I use an energy efficient wash machine, therefore I'm good, okay? But you didn't think about where it was built, how much resources were used, how it got to your house, how long you're going to use it, what happens to it at the end of life. So Hawken is actually telling us to think about that. Another source, which is great, this is a great quote. A sustainable world is not one that is slightly more environmentally responsible than it was yesterday. This is from Tom Gradle. He says a crucial importance, sustainability is the concept is an absolute, as are pregnant and unique. You cannot be sort of sustainable or partially sustainable. So that's kind of where that curve came. When I read this, I started thinking that unless you actually really bend the curve back to a sustainable level, you really can't say that you are being sustainable. Now, how this maps onto your own personal life and all the different pieces, we won't get into. But the point is that we're thinking about these technology wedges that help us bend that curve, help us get moving in the right direction. Okay. Hawken also, along with the Lovin's folks who write a lot from in Colorado, talk about how business rethinks, focusing a little bit more on manufacturing and business. If you produce the wrong materials in the wrong place at the wrong scale and deliver using the wrong business model, this is not going to lead you in the right direction. So we're thinking about business models, delivery models, ways of creating value and manufacturing that value and getting it in the hands of people and getting it either to stay with them or use it at their end of life is very important. And also importantly, we're not trying to do some sort of a trade-off or a rough optimization between three things. They have to be technical to production system to companies. They have to essentially be consistent with the definition of sustainability. So this is a big challenge, right? So we don't claim we're going to solve all these problems in a class like this, nor are we going to give you all the tools, but at least we start thinking about this, right? Start elevating our level of thinking about what it means to be sustainable and how we can use green technology and technology wedges to get closer to that. And the social part, the last portion, will be the most challenging. That's why Margot's going to talk about that part. One company you may run into, Interface Carpets. So Ray Anderson, who was the founder, he passed on recently, was very visionary. So Interface makes carpet tiles. So you could argue that carpet tiles aren't semiconductors or automobiles or jet aircraft. But essentially they have a system where they try to have as much as possible zero waste so you can recover the tiles. So we use a lot of these at the university. They're made out of recycled materials. They have a take-back technology, right? So they don't divert this stuff into landfill, et cetera. But they came up with 4 conditions. The Interface says that they try to govern their business activity. And I know we'll talk more about this under the business models, especially Elizabeth Sturkin when she comes to speak with us. Substances from the Earth's crust must not systematically increase in the biosphere, okay? Substance produced by society must not systematically increase in the biosphere. Physical basis for productivity and diversity of nature must not be systematically deteriorated. So there's a systematic system here, right? So I mean, it's sort of like we got rid of all the passenger pigeons back in the, what would that be, the early 1800s because people were eating them, so it completely wiped out a whole group, a whole population. So that's systematic deterioration. Buffalo, same kind of thing. You can name any one of a number of endangered species, the same kind of thing. There must be fair and efficient use of resources with respect to meeting human needs. Okay, so this is a company, for-profit company, very successful, and actually tries to practice this. And there's more information on how they actually accomplish that sometimes online, and we'll take a look at that also. So kind of wrap it all together, you've heard about the triple bottom line. We generally say that a sustainable business model or sustainability should include economic impacts, environmental impacts, and social impacts, okay? And this should be a harmonious interaction. It shouldn't be a trade-off, okay, saying, well, you can suffer a little bit more because we're helping the environment. There should be a way to do this in harmony. It's a challenge because you can't often define all these different terms, especially the societal impact that I mentioned. United Parcel Service published something back in 2008. So if you go online, most companies have something called a Corporate Sustainability Report, CSR. And in that, they're purporting to talk about what they are doing, at least in these 3 areas, at least in the economic and the environment area, and to some extent the social area. And it gives an assessment about what kind of resources they use, what kind of impacts they have, what their plans are. Some companies are very aggressive. By the year 2020, we expect to reduce water by this amount, or CO2, or landfill, or waste, or whatever. UPS, at least, I thought this was interesting because it sort of defines the terms. From an economic aspect, they're looking for things that strengthen the enterprise, right? So the company should be better off at the end of the year than it was before, otherwise your stockholders are going to come after you with rolled up recycled newspapers. There should be something in your work that improves the human condition. Now how you define that is a trick and needs to be teased out, but that's an important piece. And there should be things done that protect the environment, so at least shouldn't degrade the environment. And if you read the diagram, you can talk about how they apportion the functions of the business in terms of those three different categories. In a manufacturing sense, we would sort of say, at least think globally but act locally, okay? As we hone in on design and manufacturing, as we will in this class, we want to think about what's happening in the supply chain and how is the process influencing it, how is our design influencing it. are these process steps coupled or decoupled? Meaning if I change something here, does it ripple back up or back down the supply chain, or are they essentially decoupled? So a lot of the problem, a lot of the discussion that we're going to find out is actually how do you draw the control box around the area that you're looking at? Because you can, as they say, boil the ocean, right? I mean, if your company is trying to figure out how they're going to solve global poverty, it will be challenging to see how that's coupled to your business model. But to the extent you influence the world through the supply chain and through the use of your product at its end of life, you may have some very interesting things that you can do about that. We define this connectivity by use of this kind of a little cartoon that talks about, on one end is resource extraction, and then processing and fabrication of raw materials, and then conversion of raw materials, which we normally define as manufacturing. Most companies now distribute their products widely. Companies like Walmart that don't actually make anything, but actually have huge distribution networks, or other companies that rely on those distribution networks. You have to take that transportation into consideration. Then we have the use phase. Okay, so the use phase where the product is actually used. And finally, there's an end of life phase, or a reuse phase, or a recycling phase. And we would hope that some of the materials flows back into the different sections of these earlier phases in order to make better efficient use of it. Now here's something called the Comet Circle, developed by Ricoh, the copier company. This is an interesting graphic that kind of talks about this and how you measure the sort of greenness or sustainability of your system. It's a comet circle because it looks like a comet, right? It's a series of concentric ellipses. And if you look at it, what they're really saying is that the degree to which you can take a product and you can take it back from the user at its end of life, and you can take it back and reintroduce it to the user with the least amount of energy or resource or time or deterioration of its quality, that is better than if you take a lot of things or you throw the product away. So the first little loop is the user. It goes back through in-house maintenance. You're extending the life of it, and essentially the embedded energy that went into the product is still there, but you're extending the life of it. So you're fixing the old car up, you're fixing the wash machine up, and we'll talk later about, if technology is going rapidly in terms of reducing energy, that maybe you should replace some product, but if the technology is not developing that rapidly in terms of energy efficiency, then extending the life of products is a lot better. As you move out in this comet circle, you see you get back towards recycling, and you get towards shredding, and you get eventually towards landfill. That's sort of the lowest use, the highest degradation of the resource. So the comet circle idea is that the closer you are to returning the product back to productive use with a user, it doesn't have to be the same user, but a user, the better that closed loop is, and the more sustainable the whole system is. So that's reducing the impact per unit of GDP, getting more getting more value out of that product, almost inflating the denominator to make the numerator reduce in size. That's a great idea. Technology wedges do that. I didn't actually see how Ricoh employs this, but you can think the copy industry has been a great one at sort of swapping out things and taking toner cartridges back and refilling them and bringing them back and reworking copy machines, et cetera, et cetera. So something to keep in mind. I won't go through the next slide because it kind of talks about that, but you can read that on the B space. Now let's look at an example of how what might seem to be a well-established industry can have big differences or big effects on impacts per unit of GDP. If you think about automobiles and the evolution of the automobile, especially in the next 10, 15 years, we expect to see big differences in powertrains and in frames and in travel distances and in power plants, et cetera, et cetera. But in fact, most of the studies say that on average, you'd expect that still maybe by 2020 or 2025, almost half of the vehicles in the United States are going to still be internal combustion engines driven, okay? So the others will be hybrid and electric plug-ins, et cetera, hydrogen fuel cells, et cetera. You then think a little bit about where these cars are going to be built. They're going to be built all over the world. Some of the markets that are small are expanding. Some of the big markets are decreasing. I mean, I just read that in France and Europe, because of the downturn in the economy, auto production is dropping. But we know in China, India, places like that, auto production is increasing. So they're going to be built in different parts of the world. So you're sort of spreading the activity. So if you think a little bit then about the impact of manufacturing worldwide, this chart shows on the left-hand side, it shows a conversion between greenhouse gas and kilowatt hour of electricity that's produced. So we know that if you make electricity out of hydropower, or out of nuclear, or out of wind, or something else that's renewable, versus coal or natural gas or oil, you could have a big difference in the amount of equivalent CO2 that's generated for generating that unit of electricity. So the numbers in this chart that go from the very lowest in France to the very highest up in India are essentially the multiplier, and there's like a factor of 10 different between France and India, meaning that for every kilowatt hour of electricity in India, 10 times as much CO2 is generated as it is in France. So there's a big diversity. The US is somewhere in the middle, and I got a slide coming up next that talks about in the United States it varies tremendously because of the sources of power. So now you think about making an automobile somewhere in the world, okay? So we can say that to make an automobile, it's roughly 76 gigawatts of energy, okay? This is a moderate-sized car. I don't know what model it is, but let's say that's the car. So that's not driving it, that's not servicing it, that's not delivering it. That's what it takes to create the car and sort of have it available for you to pick up, the embedded energy in the vehicle. And then if you think about where you're going to make it, if you divide that number of kilowatt hours necessary to make the vehicle by the impact, you get a sense of the amount of CO2 that's generated. And not surprisingly, depending upon where you make it, France versus India, you have again about a factor of 10 difference. So if you make the vehicle in India, you have 10 times more CO2 associated with the manufacture of the car than if you did in France. Same car, same characteristics, same interior, same engine, same wheels, the whole thing, but factor of 10 difference in CO2 generated just by making the vehicle. If you look at the United States, for example, it's not quite as dramatic as that, but we're in California on the western edge of the continent, lots of renewable energy. The Prius, which is made in Kentucky, has a fairly high level, a factor of 3 greater CO2 per unit of electricity that's generated to manufacture the Prius in Kentucky than if you made it in California because of the source of the energy, right? So when you see numbers on averages for countries, these kinds of things give you the idea that depending upon the geology, the location of where you're actually building the vehicle or building the product or doing your manufacturing can either completely amplify your impact or attenuate your impact for the same level of technology, okay? So that starts people thinking a little bit about supply chains and where should I build it? Should I build something closer to the consumer because I can get advantages? Not only do I not have transportation, but I also may have a more beneficial fuel supply. So if you build your car and it shows on the bottom some of the different states of the United States. If we build them up in Washington, up in the upper northwest, because of all the hydropower, it's probably about a factor of almost a factor of 10 better than if you did it in Kentucky. And if you're building something else like a machine tool, so we're manufacturing people, if you're building machinery to do manufacturing, same calculus applies, okay? Now, why is this important? Here's an example of something from, you're going to see more stuff from Allwood, Cambridge University. A good friend of ours, rely a lot on his data. But he did a plot showing that the United Kingdom is trying to hit a 2050 carbon target that essentially says that they're going to have their 2050 levels comparable to the 1990 levels. So they've got to have about a 60% absolute cut. So if you look at the blue line, that's the cut that they have to follow. The red squiggly line is essentially where they're following based upon what's consumed in the UK compared to historically. But the orange line, the one that goes rather than down, rather embarrassingly up, is the actual emissions if it's adjusted for offshored emissions. So let's say you're buying steel to make your automobile. And let's say you don't want to make it in the UK anymore because steel is a very energy intensive business, and energy intensive generally converts into CO2 intensive. So you buy your steel from someplace else. So now you're not making it in the UK or consuming it, but you're offshoring the CO2 from the production someplace else. And in many cases, that offshored production, at least presently, if it comes from places like China, will have a higher CO2 output per unit of product than if you did it in your own home country. So the line goes in the opposite direction because they're not actually following it. They're following it by offshoring, not by making improvements in line. To make matters even worse, everybody says, well, okay, so we get our electricity and we use less electricity. For every kilowatt hour of electricity, it takes about 20 gallons of water. This is for an open loop thermoelectric power plant. So the water doesn't disappear, right? I mean, it's not like we're not creating matter or destroying matter here. But essentially, you're consuming about 21 gallons of water if you use electricity. So if you're charging your Prius, or well, I guess you don't charge a Prius, but if you're charging your Tesla, or if you think, well, fine, my whole business is going into the cloud, so I don't have to worry about it. I'm just going to use electricity from someplace else in a big server farm somewhere. Well, there's a certain amount of water that's associated with each computation that you make or each business activity that you do, because for an open loop, this is an open loop system, 20 gallons of water for every kilowatt hour. So this has to be taken into consideration. So if you want to reduce both electricity and water, you have to be both more efficient at the electricity utilization and find other sources of electricity that don't rely just on water. Okay. So we're not doomed. This is an interesting slide. It talks about progress that's been made in manufacturing over the last 100 years. So if you see where we went from sort of craft production, everybody doing their own thing, through mass production, thanks to Henry Ford and people like F.W. Taylor, scientific management, into flexible production, lean Toyota, right? Toyota production system, mass customization and personalization. Whereas you're moving along, people found that there was value that was being left on the table because of either organizational issues or lack of quality issues or control issues or something like that, meaning that if you instituted these things, you could get a higher value of output in terms of the product for a lower amount of input. Okay, so this is not an impact per GDP, but this is sort of cash generated or profit per unit of product. We would argue essentially that the very last one of these, or the next one in step, should be some sort of sustainable production. Meaning that if you actually start to consider all of the costs associated with the end of life of the product, the impact of stuff going up your stack and how it affects people living in your immediate area, cost of recycling, cost of acquiring new material, etc. Essentially, pay attention to those externalized costs, find a way to calculate those and include them in your actual cost of operation, but because you now know what they are, you would reduce them because you can find ways to reduce the impact of those, so that we're not talking about reducing profit, but we're just talking about making sure that none of the impacts or issues associated with your manufacturing operation are outsourced, okay, like health issues or training. Yeah,
and I'll just add here that in many cases, manufacturers have a choice to internalize these externalities, but in other cases, policy steps in or consumers step in to demand that the manufacturer internalize these costs. So in the state of California, we have a new cap and trade regulation, which is effectively putting a dollar value on CO2 emissions. So companies are effectively, some would argue, being taxed, but at least being charged for the CO2 emissions associated with the energy they're using.
Right, exactly. So this is something that's becoming more important, and in some cases regulations, as she mentions, will do it, consumers will drive it. Mm-hmm. The risks associated with not knowing what those externalized costs may actually drive it, if it's something that's a supply chain that goes through a particularly dangerous part of the world or where it needs materials that are in short supply. So these externalized costs have an impact on how you run your business. So we talked a little bit about these closed loop pieces, inside pieces. We're going to see a lot more of boxes and arrows when we talk more about manufacturing technology, because in fact the manufacturing relates to processes and series of processes that look like system. Now let me show you one example as we move along here. Recycling is good, don't get me wrong, but recycling may not be the lowest hanging fruit in terms of the answer. And here's what I talk about. If you think about where material goes in a manufacturing operation or a conversion process, something comes in from a previous process, something happens to it, and the output goes to the next process. Say you're taking a sheet of sheet metal and you're stamping a door panel. There's going to be some part that goes on, there's going to be some scrap. So you can actually think about what goes on to the next process and what is lost. You can calculate a yield. The yield would be essentially what goes downstream divided by the sum of all the inputs that have come up to now. Usually that's less than 1 because there's some loss along the way. And you can actually determine what's called a yield chart. So this comes from our friend Allwood, and this actually is one of the references in the reading section. And essentially you think about starting from the liquid metal and going through a series of steps that convert it to different stages of the process until you get to the final product. And along the x-axis is cumulative yield, which means what's left of that output that started in the ladle at the beginning. And he talks about mostly the major materials like aluminum and steel and things like that. And then the vertical axis essentially is the cumulative processing energy. So what is sort of the summation of all the energy that you've used to process that material up to that, up to that point? Take a look at aluminum here. And there's 3 examples given. One is a wing skin panel from an aerospace application. One is a car door panel, and one is a beverage can. And you can see that, for example, for the car door panel, you're at about 40% yield. So that means that 60% of the material that came into the factory never got into the car door panel. Now this is not because the people were sloppy or because the people were being careless or wasting material. It was because the process was not efficient enough to convert from one state of the material to the final state of the product without losing 60% of the material. Now you can say, well, I can recycle it, but sure, if you recycle it, you're going back to the melt, or in some cases, you're going back to something that's close to the melt and you're starting over again. So you're adding more energy. All you're doing is pushing yourself further up on this cumulative energy curve. So the reason we say that recycling may not be the final answer is that because there may be a lot more ability to actually try to improve the process to increase the yield. If you increase the yield by 10%, that's much better than recycling another certain percentage of the material because there's no additional energy lost. You're just processing the material more efficiently. If you look at steel, car door panels are about 50%. Now an I-beam, in this case, a structural element where it's rolled, sort of so-called net shape forming, where you start with a certain volume of material and you change the shape and it comes out in an I-beam, is actually much more efficient because you're not losing material, but in fact there is energy involved because it moves up on the scale. So we should be a little bit careful about that and think about this as the technology wedge in terms of improving the efficiency of the process to convert material from one form to another, or water from one form, or energy from one form to another. These are all ways to make some improvements. So believe it or not, we're at the end of our first lecture.
Thank you for sticking with us.
Yeah, assuming they are sticking with us. Anton is supposed to be standing at the door with a chair to make sure you stay seated. So this is kind of the yin and yang picture at the very beginning. We want to make sure that when we're done, all of the characteristics that define sustainability, especially in a manufacturing context, so water use, social impacts, material use, greenhouse gases, electricity use, environmental use, etc., are considered, and we take an existing design and we try to make the design more profitable so there's an economic benefit, but there's less impact all the way around. So it's getting that impact per unit of GDP down to the lowest possible level by any one of a number of things, right? Extending the life, using less material, by improving the yield, by having different technologies for processing, by having better efficiency in the conversion of any one of a number of things. We're going to step through all of these, I can assure you, but this is kind of what our mantra is, to try to keep our eye on that.